Hello, my name is Zhengyue Chen. I am here to present our work, Neural Network Classifier as Multi-Information Evaluator. This is a joint work by other two authors, Dongwoo Kim and Tom Gideon, from both Australian National University and Postech. The combination of softmax with cross-entropy is a standard choice to train neural network classifiers. We aim to view such a combination from a new perspective. The motivation of this work lies on two aspects. Firstly, the combination of softmax with cross-entropy measures the relationship between the output and the label. We aim to know what relation the network is modeling between the input X and the label Y. Secondly, and arguably, it may seem to be artificial to view the output of softmax as probabilities. In this work, we show that neural network classifiers can be viewed as multi-information evaluators. Before we continue, we first give the definition of multi-information. It is the expectation of the log of joint probability divided by the product of matched probabilities. As we can see, if the two variables x and y are mutually dependent, the multi-information will become zero. We then can derive a variational lower bound of multi-information as here. Furthermore, if we replace the Q part with px times py divided by the expectation of e to the power of fxy prime times e to the power of fxy, where function f is parameterized by phi, we can get a new form of the variational lower bound of multi-information. As we can see, this new form is very similar to softmax. In fact, if the dataset is balanced, that is, if each label's instance number is the same, the right-hand side of equation 1 becomes softmax. Thus, given a balanced dataset, minimizing softmax with cross-entropy is to maximize the multi-information between input and label. Next, one natural question to ask is, what if the dataset is imbalanced? In that case, we just put a prior probability of each label in the denominator. Then, minimizing the combination of this new form of softmax and the negative log likelihood is still equivalent with maximizing multi-information between input and label. We call this new form of softmax as probability correct softmax, abbreviated as PC softmax. Now, we test how accurate can our variational lower bound estimate multi-information. We use two kinds of datasets. One dataset is balanced, the other is imbalanced. For the imbalanced ones, the number of instances for each label is given in the table. The samples come from a mixture of Gaussian model with the different mu and sigma values. This slide shows how accurate can our PC softmax with a negative log likelihood evaluate the multi-information. The results are consistent with our theory. The evaluated multi-information is very similar to the ground truth values. Also, our evaluator is even more accurate than multi-information neural estimators, which uses another form of variational lower bound to estimate multi-information. Then, one may wonder whether using the new PC softmax can increase the classification accuracy. Here, we show that using PC softmax can improve the accuracy over the original softmax. In particular, when the dataset is imbalanced, PC softmax can significantly improve the classification accuracy. We have released our paper and source code. They are available through scanning these two QR codes. Thank you for your listening.